Hello, everyone, and welcome to this week's work. I wanted to check what you'd done last week before I set this week's work, just to make sure that you sort of all ordered, understood that bit, and that all looked pretty good, really. Everyone seemed to be able to do that. A quick word on some of these sort of statistical techniques and things. I know that some of you are mathematicians and scientists, or maybe do psychology, and you've learnt these things before, or you have ways of doing it. And sometimes the methods you've been taught before, they might have small differences to what I'm showing. Um, that's fine. Like if you've got a way that works and you think, well, I want to stick with my one way that works, as long as we all end up at the same answer, and that's fine. Because I think there were one or two of you that indicated maybe you had slightly different ways of doing some of those things you did in the last one. But from what I could see, everyone ended at the right answer, so that's great. So on to what I want you to try and do this week. Again, this is new for some people, but maybe if you've done statistics, or often psychology students maybe have seen some of this before. So it's something called Spearman's rank. So the first thing you need to do is go to Folders, Geographical Investigation, and then the document you want, just the one this week, is the Word document. There it is, Spearman's rank. Okay. Now this document's set up, so hopefully you can pretty much go through and sort of do the work and follow what it says on the sheet. But I'm going to just go through it quickly now to hopefully make it a bit easier. Right, first off, it's important we understand what the point is of what we're doing. So we'll come to the whole Spearman's rank and what that is in a minute. But the first thing to understand, this is where you'd be doing some sort of project or an analysis within a project where you want to establish whether there is a link between two pieces of data. So the first thing to say is that data has to be sort of paired to be able to do what we're going to do today. So a really simple example is if you had a load of people, you might think, well, I think height and weight are going to be linked. So maybe, the taller someone is, the more they'll weigh. There might be some exceptions to that and things, but you might think there's going to be a general correlation. Correlation is an important word here. A general correlation between those two things. And when I say they're paired, because each person's height goes with that person's weight, so that height and that weight go together, and you'd have lots of people, so lots of pairs of data, lots of heights and weights. Obviously we're not doing it for height and weight, so again, this is all these numbers I've just made up and invented. So in my imaginary scenario that you can see here, I've collected ward level data. A ward is just a sort of a fairly small area of a town or city. Okay, so imagine on a map you just drew around the little area. So our towns and cities are separated into wards. Okay, so just in case you're wondering what that meant. So as you can see there, I've got A to O. So they're my places I've been to. And in each place I've measured two things. And it's those two things that I want to investigate whether there's some correlation between the two. So the first thing is the percentage of people that are unemployed. In reality, if I was doing this, I probably would get that information from the census, something like that. So I find out proportion unemployed and then an EQI score. So this would be something I'd probably do myself, where I go and I might, give it a mark out of 10 for litter, graffiti, noise, greenery. You can make an EQI score to include whatever things you want are more important. But essentially here, what that's meant to mean is the higher the score, essentially the nicer, the better I thought the environment was when I did this. So maybe I think that if an area has got very low unemployment, maybe I think it will have a nicer environment because the people there have got more money and they'll spend more money on it. Maybe I think if it's high unemployment, there'll be more people around during the day and they'll look after the area. Who knows, really? For the purpose of this, it's not too important why I would think that. To be honest, they're not really two things you would necessarily expect would go together that closely. But the point is, well, you know, whatever. I've got some theory and I want to find out. So I've collected those pairs of data. So it's really important just to realise that, you know, Ward A, 3.5% unemployed, 59 on my out of 75 the EQI. Those two numbers go together and all the way down. Okay, and that's going to happen throughout any sort of calculations we do. Now, you see there, task 1. The first thing you do with this information to get a feel if there was any sort of correlation is draw a scatter graph. So again, so here you would have one of either, so unemployment on the x-axis and EQI on the y-axis. You could do it the other way around. It wouldn't particularly matter. If you're into dependent and independent variables, it's normally the dependent goes on the y-axis, but you might not know which is which, in which case it doesn't really matter for our purposes. And then obviously each plot, so Ward A, the dot on the map for Ward A, if this was on the x-axis, I'd go across to 3.5 up to 59, sorry, and put my dot there. And likewise, I'd do them all the way down. When I do that on a scatter graph, by the way, there's no need to label them as A, B, C, D, etc. Because in a way, once I'm doing that, I'm not interested in where that information came from as such, because all I'm interested in is there a link between unemployment and EQI score? Okay, so there's no need to put like point A, point B on your work. Right, so draw a scatter graph. If appropriate, draw a line of best fit. So the line of best fit, so if you've got your scatter graph and you've got all your points on there, sometimes if there is a pattern, and the pattern will either be, so going from, say, the points will look like they go largely from the bottom left to the top right, or from the top left to the bottom right. Normally, they're your two sort of possibilities. And if they look like that, normally what you can do is draw a line going through sort of the middle of the points. So not necessarily touching all the points, but just going through the middle of them to show sort of what the pattern is. A line of best fit should, if it's drawn correctly, have the same number of points above it as below it. So if you've got 20 dots on your scatter graph, a line of best fit should have 10 above it and 10 below it. The reason I said draw a line of best fit if appropriate is sometimes you draw the thing and there is no pattern, there's dots all over the place. Well, there's no line of best fit if that's the case. You can't draw anything. Now, it's a while ago I made up these numbers, but knowing me, I probably made them up, so there is going to be some sort of correlation so we can do the whole exercise. So probably you will be able to try and draw a line of best fit. Once you've done that, you write a paragraph to evaluate whether there is a relationship and which way round the relationship is. So is it that so is it a positive correlation? In other words, as one increases, the other one increases too, or is it a negative correlation? So as one increases, the other decreases. They're the two types of correlation you can get. A quick point here, when you're saying, like if you were doing this and you say you got the correlation, that's what you found out. There's a correlation. As one goes up, so does the other one, or as one goes up, the other one goes down. What you haven't found is something called a causal link. So what I can say is, for example, as one goes up, so does the other one. What I can't say is this one goes up because of that one, or this one goes down because of that one. You can't do that because, of course, there could be something else we haven't measured that's making them both go up or both go, or whatever it is. So it's important just to realise that you can't overstate what you found out. You don't know that one is making the other one do something, but what you can maybe see is a pattern that they both go up together, or one goes up and one goes down. Right, that's the first thing. And if you do this for real, that's what you do. Now, if you drew that